Let's set up our project first. So currently I've opened an empty Unity project and its name is Sudoku because the game we are going to create is Sudoku, and it has the sample scene at the start. Now what we are going to do is create a new scene and we'll call this scene and we'll save it, and it is going to be inside the scenes folder, and we'll rename the scene as gameplay, and we'll delete our sample scene. And after deleting our sample scene, we'll need to add our assets. So for our assets, I'm just going to use the default ones that we have in Unity, but we are going to need the colors, so it should be inside an editor folder. So I'll bring in the editor folder inside our assets. So as you can see, the colors as all the colors available, and after that I'll create the rest of the folders which are for the prefabs, and there is one more for the scripts, and finally there's going to be one more for TextMesh Pro, but we will install it so it will be automatically created. And after that, let's start with our build settings. So let's remove our sample scene and we'll switch our platform to Android, so there are not any errors and our packages works fine. So it will take a couple of seconds. And it should be finished by now. Okay, so now it is finished, and what we are going to do is set up our project settings, and inside our build settings we'll need to add our current scene. So first we'll need to import TextMesh Pro and disable the warnings, and that is not toolchain management, so we don't need to do anything for that, and it will take a couple more seconds, and it should import TextMesh Pro for us, and you should be able to see a folder here. So TextMesh Pro is installed and we'll disable the warnings, and after that inside the editor let's change the naming to use underscore. Now we are going to set up our packages, so let's open the package manager, and as you can see there are so many packages. We are just going to need the 5 of them including the 2D, and we'll remove all the packages. If you don't want, you can't, you can, but what those packages add up is going to be the build size, so test framework, so it will be extra added, and visual scripting also, it almost adds like 20 to 30 megabytes of extra size when you build it, but we are just going to create the game and look at the puzzle, so it doesn't matter, but I do it every time, so I'll just show it. And we won't need the version control, but if you are using any professional project, so if you want to create some game and want to add some modifications, so the version control is used along with plastic SCM, which is better than GitHub. And for games it is better than GitHub, depends on how you want to use it. If you just want to like not create too complicated pipelines, then it won't matter. And as I'm using Visual Studio, I'm going to remove the VS Code editor, and that should be it for the packages. And what should be remaining is let it update and we'll create the rest of our scripts. So the scripts we'll need to create are first the generator, which is going to give us the puzzles, and after that we are going to have a solver which is going to return solved puzzles, and we are going to need a cell script which is for an individual cell, and also a subgrid script which create gets the reference to all the cells for that subgrid. So subgrid is just our 3 cross 3 subgrid inside our 9 cross 9 Sudoku grid. And finally we are going to need our game manager script, and everything is named correctly, and now we won't need to add anything, so let's close. Yeah, we'll need this, and instead of free aspect we'll have it use portrait landscape. Let's have it use portrait, and it is showing some errors but doesn't not we don't just clear it. So everything's perfectly set up, and now we'll start coding our game. So in the previous part we set up our project. Now what we are going to create first is the Sudoku generator script, which is yeah, maybe Sudoku solver. We'll see which we'll need to create. So we'll first create the Sudoku solver script. So it is pretty simple, and after that we are going to create the Sudoku generator script. So let's go inside Unity and we'll open our solver, and it should take us to Visual Studio, which you can see in my screen. And we are not going to need mono behavior, it is going to have all the static methods, so we'll need to delete our start and the update, and also our Unity engine. No generic classes will be needed. So what is going to be inside our Sudoku solver? So the first is going to be int for our board size, and this is going to be 9, and after that we are going to have private constant our subgrid size, which is going to be 3, and private constant string, not string, int empty cell. So our empty cell is going to be denoted by 0, and let's create our first method. So public static, and it is going to return an our grid, which is a 2D array, and we'll call it solve Sudoku. And the parameter we are going to pass is another grid, which is our unsolved puzzle, and it is going to solve and return our solved part. And after that let's create a new array, which is going to be our result, so we'll call this solved puzzle, and it is going to be our new int and of board size. And after that we'll use array.copy, and we are going to copy unsolved puzzle to our solved puzzle, and the size we are going to use is the unsolved puzzle dot length. And what it is going to do is we'll create a backtrack method, which is going to solve puzzle, and the starting index is going to be 0 and 0, and after that we are going to return our solved puzzle. So let's see what our backtrack method is going to do. So we are going to have a private static bool, and this is our backtrack, and it takes a parameter of our 2D array, which is our puzzle, and the next two indexes are our row and our column. So how we are going to implement this backtrack? So if everything is passed, that means there are no solutions, so we'll return false. And we started at 0 0, and if our row is equals to board size, then we'll return true. That means we just checked all the previous cells, and when the row is board size, so it is 9, and our index is from 0 to 8, as our grid size is 9 cross 9, so the last index will be 8, so it will be returned true. And if our column is equals to board size, that means we'll need to backtrack. And what we are going to backtrack, first we'll pass the puzzle, and we will go to the next row, and finally the column we are going to start is 0. Else what we'll need to do, so we'll need to check our current solution. So how we are going to check, so let's see if puzzle of our row and column is equal to 0, that means okay, it is not equal to 0, that means you don't need to solve it. Then we are going to return backtrack, and we'll pass the puzzle, the column is going row is going to remain the same, and we'll pass the column plus 1, so it is going to pass on to the next cell. Now for int I is equals to 0, I less than board size. Okay, so we'll need to check for the values which are 1 to 9, and what we'll do if is valid, and we'll need to create, okay, so this is just the solver, so we'll pass the row, the column, and finally the value which is I. And if it is valid, then we'll set the puzzle for the row and column to be equal to I. And if backtrack of puzzle row column plus 1, then we are going to return true. And let's also yeah, because that looks better. And we'll need to create our isValid function, and if it is not, then we are going to reset it. So puzzle and row column plus 1 is going to be equal to 0, which was uh, already 0, and at the end it is going to return false. And after that, let's create our valid. So again it is going to return a bool, and it is called is valid, and here we are going to pass our array which is our grid, and we'll call this board, and we need to pass the row, the column, and finally the value. So what value need to check, and if none of the value matches, then we are going to return true, else we are going to return false. So when we are going to return false, so let's create our first for loop for int I is equals to 0, I less than board size, and if board at row comma I is equals to value. So if it is equal to value, then we are going to return false. So it is going to be checking the same row, and after that we'll copy this line, and here we are going to checking the column, and finally we are going to check our subgrid. So we'll need to get the subgrid row, which should be row divided by subgrid size and multiplied by our subgrid size. And similarly we are going to have our subgrid call, which is going to be call divided by subgrid size multiply by subgrid size, and we are going to have loop here. So for int r is equals to subgrid row r less than subgrid row plus subgrid size, and we are going to have one more loop which is going to be c is equals to subgrid call and c less than subgrid call plus subgrid size c plus plus. And again we'll check if our board at r and c is equals to value, then we are going to return false, or else every other condition is going to return true. So this is our is valid, and our solver is going to have one more method to check if there are any possible unique solutions. So I'll need to create that. And so the method is called public static bool of has unique solutions. So is valid, let's create it after backtrack. So public static bool has unique solutions, and here we need to pass our board and after passing the board, let's first get our solution count and we'll set it to 0. And after that we need to find our empty cell, which is row equal to -1 and column is equals to -1. And for int r is equals to 0, r less than board size, and for int c is equals to 0, c less than board size if our board and r and c is equals to 0. So we need an empty cell, which should we will pass our empty cell value, then we'll set the row to be equal to r and column to be equal to c, and then we'll break. And after we break from the for loop, we'll check if our current row is not equal to -1. That means we got the first cell, which is valid because its value will be from 0 till 8. Then after getting that first cell, we are going to find its number of not number, if solution. So if our row was -1, that means it is just one row and not uh, just one whole board, and there were no empty positions, and we found a valid solution, and that is just the unique solution. So with no empty cells, that is just going to be one solution. So that is a unique solution. And after that, what we are going to do is for int value is equals to 1 and value is less than equal to board size, we'll try each of the values for our empty cell. So if is valid, and here we need to pass our board and our row and column and finally a value. So if it is valid, then we need to check if we'll first set our value, and if has unique solution, Okay, so our board then will increase the solution count, else if not else if our solution count is greater than 1, then we are going to return false because we need a unique solution. And at the end we'll set the board at the row and to be an empty cell, so it is just going to reset everything and check all the other values. So all the values will be checked, so if there exists a unique solution for any one value, and if there exists one more unique solution for any other value, so for one it may exist, for any other value also it may exist, and the solution count will increase. And whenever there is more than one solution, so this should be passed only once, but if there is any false any other number which has a solution, then it the solution count will be greater than 1 and it will return false. And whenever everything is passed, we need to check if our solution count is equals to 1. So we need exactly one solution, and that's what our what method has unique solution is going to do. So that was our solver, and after that we need to also add our generator, which is going to help us generate the Sudoku puzzles. So we'll do it in the next part. So in the previous part we created our first script, which was the solver. So it is going to solve any particular grid, and also it has a method for checking if any grid has any unique solution. So that was there, and in our current script we are going to create our generator script. So again it is going to have static methods to uh, generate a valid grid. So let's start with what we can do from the previous part. So we are going to need the isValid method here. So extend calls are a little bit expensive, so I'm just going to create that method here, and it is going to require some variables. So let's add that, and I'll add from the start. So first we are going to have a public enum, and it is going to be our difficulty level, and it is going to have an easy and medium and finally difficult. And after that we are going to have private constant of grid size or board size, whatever you want to call it. So 9, again private constant int subgrid size, and our subgrid size is 3, and private const int board size, and our board size is 9. And after that we are going to have private const int min squares removed, and they are going to be 30. And finally private constant max squares removed, and the maximum is going to be 50. And after that we are going to need a private static void shuffle, and it is going to be of type T, and the parameters are going to be list T, and we'll call this list. And let's get n is equals to list dot count, and while n is greater than 1, n minus minus int k is equals to random dot range. Okay, random unity dot random dot okay, so random dot range unity dot mathematics collection system dot collections dot generic. So what I was using unity engine. Mm-hmm, 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 mm-hmm. Do I need the system? No, system dot collections dot generic is more than enough. So now the random, yeah, so it is not creating problems now. And we'll get that from our list of k, and our list of k is going to be list of n, and our list of n is going to be temp, so it is going to swap our current index with a random indexed value, and we'll see how we are going to use it. So these were the two methods that were created at start, and after that we are going to have two more methods, which is not two, three. So let's create our first method. So it is going to give us an initialize grid, so valid Sudoku grid, and all the cells will be filled, and we need to pass our grid. So how we are going to do is let's create a list of numbers first. So list int of numbers is going to be new list int, and 1 2 3 4 5 6 7 8 9, and after that we have created the list. We'll shuffle our numbers, and after shuffling our numbers, let's do for int I is equals to 0, I less than board size, grid size, board size, whatever, grid size, and we can just directly set the 0th column and the 0th row and the ith column, and it is going to be numbers of I, and after that we will fill the rest of the grid, and we'll start from the first row, 0th column, and the value will need to pass is our grid, and it is going to be a private static and return a bool, and it is fill grid and int row call, and finally our grid. And at the end we are going to return false, and our grid and RNC is going to be 0. Backtrack to the previous cell. It won't be needed, but it would be good if we just set it to 0. And again, if R is equals to board size, then we are going to return true, and if C is equals to board size, then we'll need to return fill grid, not fill, grid size, grid size. So we'll need to return fill grid and RCN grid, but R is going to be increased by 1. And after that, if none of the values work, then we'll need to try all the values, which should be our this part. So list int numbers for int so get a list of numbers and shuffle it, and for each var num in our numbers, if is valid, so we'll need to pass here. So our number should be valid for that row, column, and our grid. And okay, so now Marcy. So our value needs to be first. Then we are going to have our row, column, and our board. So if it is valid, and we'll set that value, which should be row and the column, to be equal to a number. But and okay, so that was just setting it up. And if our we are able to fill the grid, then we'll return true, or else it is just going to check the next value. And at the end, if none of the values work, then this is going to just set the values to 0, so no errors occur. So this is our fill grid, and in our initialize grid we are filling the grids. Now let's create the main method, which is going to generate our levels. So again, it is going to be static, and it is going to return our 2D grid, which is our what is happening. So it is going to return a 2D grid, and we'll call this generate puzzle. And inside our generate puzzle, we are going to pass the parameter for the difficulty level. Let's create new int of grid size, comma grid size, and int our squares to remove is going to be 0, and we are going to switch on our difficulty level, and case easy, then our squares to remove is going to be random dot range, and it is going to be min squares removed comma min squares removed plus 5, and we'll break. And case medium, squares to remove is going to be random dot range from min squares removed plus 5 to 10. And then we are going to break, and again case difficulty level dot difficult, our squares to remove is going to be random dot range from min squares removed plus 10 to max squares removed. And after that it is going to break, and after the number of squares we have initialized, we'll initialize our grid. ini private static void initialize grid. Okay, ini tia initialize grid, and we need to pass the grid, but why is that the name does not exist? Public static and private static void. Maybe I think don't know why is our initialize grid not working. Does not exist in the current context. Show potential fixes, generate method. Private static void. Hmm. I already created that method. I think I know. So on default and we'll do break. Mm, 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 So my initialize method is not working, and public class it does not inherit from the mono behavior. Generate puzzle. Let's have it return our grid at the end. Return grid. INITIA. So where is the problem? So let's delete that. No issues found, and configure code cleanup. KD save, and our solver was also working fine. Okay, fill grid. Grid at 0 I, numbers of I, shuffle of numbers, private static void. There's some background noise, so I don't know. TINIT. So let's private member is unused. How about we make it public, and now initialize grid. So let's just pass, and we'll be able to see what error is there, and let's generate method in. Okay, so I got it, the name was wrong. So actually it is INITIALIZA. Okay, just the name was wrong, no errors, and if you wasted so much time, then sorry. And we'll start creating again. So while our squares to remove are greater than 0, we need to remove that squares, and this method is not the perfect one, but actually I used ChatGPT to generate the puzzles, and it gave us this method, and that's what we are going to use, and it is going to be 0 dot board size, and similarly our random column. So it generates puzzles every time, but there is a chance that it may break. Maybe small amount of chance, but then we'll check if our grid at our random row comma random call is not equal to 0, then we can do something. So let's first get the value, which should be grid add random row and random call, and we'll set this value to 0, and we'll check if our solver dot has unique solution. So it is emptied, and we'll pass the grid, and we'll remove that square. So squares to remove minus minus, and if it does not have, then we'll reassign. So grid at the random row comma random call, and that is going to be equal to temp. So we'll reassign, and it will start checking for another value. So pretty straightforward, nothing too complicated, and when there are no squares to remove, the function is going to end. Most of the time it ends, but I don't know if there will be some edge cases like we did in our previous part, which is our connect game. So it works for almost all the checks, and there are not any problem. So these were the main two, generator and the solver script. So if you want to solve any Sudoku puzzle or generate any of them, then you can directly use these two classes, and both are static ones, so there are not any different game objects or setting up involved, you can just directly use it wherever you want. And as it is created in C hash, so you can use it for C++ or maybe even Java. So it will give you valid Sudoku puzzles. So that was it for this part, and in the next part we'll first start by spawning our grid. So we have created our two scripts which are going to generate our grids, which is our solver and generator. We are not going to use the solver script for now, which I intended to use for if you want to instantly skip the level or just visualizing, but just the generator script was enough. So this is our gameplay scene. I have not made any changes for now. Now this is the color palette that we are going to use. Okay, so capture cursor, I forgot that. Yeah, now there should not be any more problems. Is it recording? Okay, so now what we are going to do is set up our scene. So let's set the color of our main camera and let's change our swatch to use the colors. So our background is going to be the dark gray color and our camera size is going to be 36. And after that we will create our game manager, and here we are going to attach our game manager script. And let's create our first UI for the level text, and it is going to be from the top, and the canvas is going to set on the screen space camera, and our canvas always needs to be on top, so let's set it at around 100, and it is going to scale with screen size 1080 by 1920, and will match the height. And let's put it at negative 10 to 4 by 256, and let's align both of them at the center, and it's just going to call level 2 or whatever level you want. So nothing too complicated. And softness, let's increase softness, no dilation. I'm just having make it look a little bit good, and a little bit of no need for outline. Let's have the color a little bit brighter, and we'll decrease the softness so it looks good. And let's just have it at 0, so it just made a little bit brighter. And after that, let's create our restart button. So let's just use the default one. It looks good, already good enough. So 128 size is better than yeah. And inside our scene, it is position. Now let's create our button, which is just going to be an image, and it is going to be aligned towards the left, and it is going to be -8. Let's change this width and height. So I'm not going to make it more complicated, so this is just going to be looking the default one, and let's also change its color. And what color should we make it? Blue, black. So it should be 0046, and our image will call it restart, and it is going to have button component attached, and nothing else. Now we are going to create our input button. So for that we'll create an empty and we'll call them as input buttons. Let's reset its transform, scale it across the whole screen, and we are going to attach a grid layout group. And for the grid layout group we'll add a padding of 64, and the cell size is going to be 160, and the spacing is going to be 32. Upper left horizontal, lower center, and we will have it as fixed row count of 2. So we just need to have it attached to, and let's create an image and we'll call this input, and start corner is going to be upper left. Okay, so it is going to be at lower left. Yeah. So the start corner is going to be lower left, and after that we will it also, let's create a UI and we'll attach a text and scale it across the whole. Let's have it auto size, and let's increase the max. We'll also increase its color to blue, and this color is going to be gray. And for the text we'll just call it 5, align it to the center, and as you can see this is going to be a button, and we'll rename it to X. And what we are going to do is save this as a prefab. So our input is also going to have button component, and we'll set the color tint to none, and I'll say it as a prefab in my prefab, and we'll rename this to input under slash 1. Now let's duplicate it multiple times, and our input 1 text is going to be 1. Now let's see, does our text is at 1? So it is not at 1. Lower center, lower left. Okay, it needs to be at lower center. Start corner is going to be upper left. Okay, so now it is at the correct position, and we'll also set the text for rest of the inputs. 3, 4, 5, 6, 7, 8, and 9. So this is going to be our input field, and we already had it assigned 2160 by 1080 portrait. Okay, so it is set to scale with screen size and will match the width. So how it looks in the landscape, we need to match the height, 1080 by 2160. So now it's looking better. And now next we are going to need our background, and our main camera is our solid black color, and let's create an empty and we'll rename it to BG. We'll reset its transform and attach a sprite render component, and for the sprite we are going to use the square sprite, so it should be the default sprite assigned. Let's make it sliced, and the size is going to be 29, and its color is going to be black because this is going to be our border. And now we are going to create our cell, so let's rename this to cell, reset its transform, and we should be able to see our cell here. And first we are going to attach a sprite render component, and again the sprite is going to be our square, And instead of simple, we'll make it slice. The size is going to be 3.08, and for now the color we are going to use our dark color. And after that is also going to need a box collider 2D, which is going to be a trigger cause we'll need to detect touch on it. And let's create text, and the canvas we are going to need it on the wall space, and it is going to be on top. So our cell has a background, so its background is going to be at 0. And after that we are going to have our text, so its background needs to be a higher, so it should be inside our ordering layer, so we'll set it to 2. And let's set its 0, and size is going to be 3 cross 3. And let's also set hmm, so minimum, let's put it at 0, and the text we are just going to call as 7. So if we go inside our game, you should be able to see that this is our text. And for the material, let's make it a little bit more brighter so it looks good. And let's make it a little bit more softer. I don't want to change much, so underlay also, does it look good? Mm, so let's leave the underlay. So this is going to be our cell, and it is going to be aligned everywhere else, and we are going to save the cell as a prefab. Now let's delete the cell, and we'll create an empty, and we'll call this subgrid. And also in our cell we'll need to add our cell script, and let's create our subgrid as a prefab, and we'll go inside the scene. Let's reset its transform, and we'll attach a sprite renderer component, and here the sprite we are going to use is our square sprite, and we'll make it sliced, and the size is going to be 9.48, and its color is going to be our mm, dark gray. We'll see what color we'll need to use, and it is going to need the subgrid sprite. And what we are going to do is attach our cell to it. So as you can see, our cell is attached here, and we'll rename this cell to 1, and we'll add one more cell, and it is going to be positioned at negative 3.08, and this one at positive, and we'll duplicate this, and this is going to be at positive, and again we'll duplicate this, and this is going to be at negative. So if we paste our subgrid, you should be able to see that it is looking like our current grid, and we are not able to see it clearly because yeah, so let's set its color to what color did we change? Text input. Okay, so we change the text color, and now its background color. Hmm, hmm, hmm. Let's go inside our cell first. So our cell's background color is going to be the dark, and its text color is going to be our gray. So why is it not looking grayish enough? Because of the brightness, color, HDR, intensity. Let's just use the default one. Let's reset so it looks better. And this is going to be a default cell, and inside our subgrid now again. Okay, so uh, cell is going to be 3 and 3. How is it going to be? Yeah, so let's set it at 3 and 3. Now our subgrid should look with borders. And if we place our subgrid, we should be, yeah, we are not able to see it because our cell color is black here and our cell color is black. Our background color. Okay, so because of the ordering layer, our background needs to be at -1. And now again. Okay, so the subgrid's background needs to be at -1 and our cell's background is at 0. Our canvas layer is at 1 and our overall background needs to be at the -10. So that was just the ordering. So as you can see, this is our grid and that's how it's going to look. And what we need to do is spawn this grid. uh, yeah, so we'll need to spawn this grid and we have created almost all the prefabs. So in the next part we'll set up our game manager to spawn all of the grids. So now we need to spawn our grids and we'll need to start coding our logic for the game manager and also our cell. So we'll first start by creating how the initial look of our cell is going to be, and also all the starting setup that we need to do, like we'll need to grid and the initial variables. So let's go inside Visual Studio and we'll first by uh, setting our subgrid. So our subgrid is just going to have a private list of cell, and these are going to be the cells that we'll need to reference, and we are going to spawn the subgrids, and depending on this order we'll initialize our 2D grid inside our game manager. And let's see what we are going to need inside our cell. So our cell is going to mostly have the colors and the variables. So uh, first let's create a serialized field, private int not. So first one is going to be the value, uh, mm, hide an inspector. Then we are going to have the value for the row and the column, and we'll just call it call, and hide an inspector public bool. And this one, if it is locked, we need to check if it is locked, and also hide an inspector if it is incorrect, or yeah, if it is incorrect. So if it is incorrect, then the game is not going to be finished. And after that we are going to have a sprite renderer reference, and this is going to be our background sprite, and we are also going to need the text, which is going to be our value text. And yeah, so I'm not going to record the cursor here. And after that we are going to need all the color values, so what state our color should be in. So let's create a serialized field, and this is going to be our private color. And first let's have our start unlocked color, and start unlocked cell color, and after we are going to have color start unlocked text color. So if anything is unlocked, then we are going to set its values, and we are going to have start lock cell color and private color start locked text color. And we'll need an initializer, so we'll create a public void in it, and we'll need to pass the value, and we'll set the value, and is incorrect is going to be false, and if our value is 0, then we'll set the lock to be true, else our locked is going to be false. And our background sprite dot color is going to be, if it is 0, that means it is unlocked, so start unlocked cell color. And our value text dot color is going to be start unlock cell color, and our value text dot text is going to be an empty string. And after that, let's copy the previous part, and here our value text is going to be our value dot toString, and here instead of start unlocked we'll have start lock cell color and start lock text color. So it is going to initialize our values, and hmm, hmm, hmm. And that should be it for our cell, our subgrid as the list. Now what we are going to do inside our game manager, so let's create all the variables and everything that we are going to need. So it is going to need a couple of one. Let's first create a serialized field vector3 for our starting position where we need to start to spawn. Serialized field private float offset x and offset y, and serialized field private, and we are going to need the subgrid, and we'll just call it subgrid prefab. And after that, serialized field private tmp text, and we will need the level text. We'll not set the level for now, but we are going to use it later. It is good to create everything at the start. Private bool for has game finished. Then our private cell, and it is going to be a 2D grid, and we'll just call it cells, and private and cell, and this is going to be our selected cell. So whenever we select, we'll need to save it. And private constant, and this is going to be our grid size, and it is going to be 9. And private constant, our subgrid size, and it is going to be 3. And inside our start, okay, so there was an error here instead of end. So inside our, what is the problem? Okay, we don't need the threading. Okay, unity engine dot player loop, unity engine dot start, awake system.runtime.compiler services. Why is it creating problems? So we created everything and we need our start method, which should be the private void start. Unity message, zero reference. There is some issue here. So let's create our update method. Public class game manager inherits from the mono behavior. My autocorrect is not working correctly, maybe. So what is the problem? Cell collections and generic are not going to need it. Generator, solver, and the game manager. GAME class game manager. Okay. Start system unity engine dot UI elements. Mm, mm, mm. Show only classes. Okay, it needs to be turned off. There should be the start method. I don't know what happened. Unity engine dot player loop. So cell created an init method. Let's try here. It is also not here. Maybe it caused some issues. So what I'm going to do is let's go inside Unity and I'll just restart my Visual Studio. You should be able to see it in a second. So let's go inside our script. Let's open the game manager and it should be opened in a second. Now let's go inside Visual Studio. So yeah, so that was just some problem. I don't know what happened. So inside our start, we are going to set up all the variables. So the first is going to be hash game finished, which is going to be false, and our cells is going to be new cell of grid size comma grid size, and our selected cell is going to be null, and we'll spawn the cells, which function will need to create it. The function will need to create it. Let's create our spawn cells function. So private void spawn cells, and inside our spawn cells let's get our puzzle grid. And for the puzzle grid we are just going to get it from our generator dot generate puzzle and generator dot difficulty level dot let's create an easy one. So it is going to give us our grid, and after that we are going to spawn all of our subgrids. So for int I is equals to 0, I less than grid size, and vector 3 spawn position is going to be start pos plus I %3, and we'll multiply it by offset x. So the first one is going to be spawned at the first row plus and v3 dot right plus I divided by 3 multi. Okay, so offset x multiplied by v3 dot right divided by 3 multiplied by offset y and will multiply it by v3 dot up. So it is going to set up the spawn pose, and after that we'll spawn our subgrid, which is going to be our subgrid, and we'll instantiate it, and we are going to instantiate our subgrid prefab, and we are going to instantiate at spawn pose and quaternion dot identity, and we'll get the list of cell, and we already renamed this to cells, so what should we call it? We'll call this as subgrid cells, and it is going to be subgrid dot public. Okay, we needed it to be public, and cells, and now we need to set up all those cells. So our start row is going to be our I divided by 3, so our row is going to be at the start, and we'll multiply it by 3, and similarly our start call is going to be I percent 3, and we'll multiply it by 3. So the row is going to be from the bottom top 3, and our column is going to increase, and we'll loop for int j is equals to 0, j less than grid size. Our subgrid cells of j and its row, it is going to be our start row plus j divided by 3. So row is not going to change for the starting cells, and our column is going to change, and here we'll use the percentage, and after both of them are set, we need to get the value which should be inside our puzzle grid, and it should be subgrid cells of j dot row and subgrid cells of j dot call, and after getting the value we'll need to initialize it. So subgrid cells of j dot init, and we'll pass the cell value, and we need to set up our cells. So cells at the row and the column, which is our subgrid cells at j dot row comma subgrid cells at j dot column is going to be our subgrid cells of j, and this should initialize it, and I don't think it will create any more problems. So yeah, so we are spawning it. Let's set up all the values and we'll see how it goes. So inside our game manager, let's set up our starting pose, which should be 9.48. Yeah, so it is negative 9.48. The starting position is going to be start from there, and the offset is going to be 9.48, and our subgrid prefab should be inside our prefabs, and our level text is going to be from our levels, and we'll just rename this as restart. So let's attach the level. Now let's go inside the cell. We'll need to attach the background sprite, and the value text, and our start unlocked cell color is going to be gray, and text is going to be blue, locked is going to be dark gray, and the text color is going to be light gray. And we need to initialize our subgrid. So our subgrid, it adds everything from here to here. So let's click on our subgrid, and let's mm, mm, mm. So first one is going to be our 8, then we have our 9, and finally it is going to be our 7. Is it 7? Yeah. And after that we need to add this one, which is going to be 2, and the center one, which is going to be 1. So they are like, instead of spawning, I just assigned them here, so it doesn't create any issues. And this is going to be our 6 and 4. Next we are going to have 5, and finally this one is going to be our 6. So 8, let's check. Okay, the first one, the second one, the third one, and the fourth one, fifth, fourth, fifth, sixth, seventh, and eighth. So there are not any more problems, then we should be able to just see our level spawning. So let's see what errors it is going to give. And it didn't give any error, but everything is blue, 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 blue. So somewhere inside our cell color, so let's see. So start lock cell color is going to be why didn't it change the alpha? Text color, start unlock text color is going to be blue. So let's now play. So as you can see, it worked pretty fine. And we'll need to change the colors. So what color will need to change? So background is right, but mm, subgrid's background color will need to change it to a darker hue. Now let's hit play. So now it is looking good enough, but still there is this border, and we'll make this border black, so that should be our subgrid. Yeah, let's make it pure black, and now we should be able to see the differences. And again, it is looking ugly, but it doesn't matter. So that's how the color is going to look, and there were not any errors, and we were able to spawn everything correctly. And in the next part we'll see how we are going to input and highlight, and finally we'll see how the mm, we'll first start with the input. So as you can see, we generated a level, and every time it is going to give us new levels, so 3, 7, 4, 5, and all the levels should be perfectly fine. We should be able to solve it. And so let's go into the next part. So in the previous part, we have spawned all of our levels, and now we need a method to update our grids. So we'll need to create that. And we'll start by directly going into the scripting part. So let's go inside Visual Studio and let's start with hmm, 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 updating our input. So let's start by adding the methods to our cell. So inside our cell we'll need different methods, which is going to be, first method is for highlight, and inside our highlight we are going to need more colors. So serialize field private color, and this is going to be our highlight. And whenever we highlight, if it is locked, then it is going to have some color. And highlight text color, highlight unlocked text color, and serialize field, highlight cell color, and serialize field private color. We will also need, if anything is wrong, so it is going to have a different color, wrong cell color, and serialize field private color, highlight wrong text color. And after that, when we are going to select it again, it is going to have selected cell color and selected text color and selected wrong text color, and again we are going to have selected wrong cell color. So let's put a space here, space here. Let's add a header, highlighted, header for selected, and finally we are going to have serialize field for our private color when everything is reset. So reset cell color, space, header, text color, serialize field private color, reset wrong cell color. So when everything is resetted, it is going to have a different color, and reset wrong text color. So these are going to be all the variables we are going to need, and whenever we are going to highlight, we will first check if it is locked. If it is locked, then we'll set our background sprite dot color to be equal to our highlight locked cell color, and our value text dot color is going to be highlight locked text color. And if it is not, then we'll check if it is incorrect. Then we'll set the background sprite dot color to be equal to highlight wrong cell color, and our value text dot color to be our highlight wrong. And if it is not, then it is going to be our highlight unlocked cell color, and our value text dot color is going to be highlight unlocked text color. So that is going to be for the highlight. Whenever we highlight it, we also need to create a method when we select something, and whenever we select, we are not going to check if it is locked, because the locked ones are not going to select it, and we will only able to select if it is unlocked, and it's just going to have two conditions: if it is incorrect or it is correct. So if it is incorrect, then our background sprite dot color is going to be selected wrong cell color, and our value text dot color is going to be selected wrong cell color. Else our background sprite dot color is going to be selected cell color, and our value text dot color is going to be selected text color. And after we select, we are going to need one more for the reset. So it is going to be similar to highlight, similar conditions, and instead of highlight we'll call this reset, and if it is lock, then we'll just set it to start lock cell color and start lock text color. And if it is incorrect, then it is going to be reset wrong cell color and reset wrong text color. And again we are going to have reset cell color and our reset text color. So that is going to be for the reset condition. We will also need to create a method to update the value, and the value needs to be passed, and our value is going to be value, and value text dot text, it is going to be, if our value is 0, then it is going to be empty, or else it is just going to be value dot toString. And finally, when we win, so public void win, update win. So our background sprite dot color, everything is going to be our lock. So, and our value text dot color is going to be start lock cell color. So that is going to be all the situations for our cell. And after our cell has been set up, let's go inside the game manager and set rest of the things. So we updated the spawn cell and create get go to next. So we are going to get the input in the update. So if the game has finished or not, input dot get mouse button down of not down, get mouse button of 0, then we are directly going to return. Else let's get the mouse position first, is equals to camera dot main dot screen to world point, and we'll pass the input dot mouse position, and we'll create a vector2 for mouse pose 2D, and it is going to be new vector2, and we'll pass our mouse pose dot x and mouse pose dot y, and we'll use a raycasted 2D, and we'll call it hit, and it is going to use physics 2D dot raycast, and the position is going to be mouse pose 2D, and the direction is going to be 0, so it will hit a point. And if so if we have hit or and hit dot collider dot try get component, and we'll need to create our cell, and we'll call it temp cell. Hit dot collider dot try get component, and we'll pass our out temp cell, and so there needs to be uh, our script component, and after that it should not be equal to selected cell, and it should not be locked. So if it is locked, then we are going to return, and that's what the end condition is going to do. So if any of this condition does not match, then we are going to return, at least even if one does not match. And after that, what we'll do is first we'll reset the grid, and after that we'll set our selected cell to be equal to our temp cell, and we'll call the highlight. Reset and highlight. Okay, highlight state where non-invocable. So let's create our reset grid method. So private void reset grid, and inside our reset grid we are just going to use two for loops, which is going to go inside our grid size and just cells at ij.reset, and private void highlight, and inside our highlight we'll first set the incorrect state. So for int I is equals to 0, for int j is equals to 0, cells at I comma j dot is incorrect, so we would have selected, yeah, yeah, we'll need the highlight. So we need to set the incorrect, and we'll need to create the method. So not is valid, and we need to pass the cells of I and j, and also our grid list. And let's create a method which is going to return if it is valid, and we'll need to pass the cell and our cell grid of cells, and everything is true, then we are going to return true. So when it is not going to be true, so let's get the row and the call. So it is going to be from the cell dot row and call, and our value is going to be cell dot value, and if our value is 0, then we are going to return true, else we'll check for grid size if our grid not grid, if our cells at I row comma I dot value not cell, cells at row comma I dot value is equals to value, and we need to set the cell dot value to be 0 first. Then we are going to return false, and again we'll pass I comma call. Then it is also going to return false, and now we need to check the subgrids. Cell dot value is going to be equal to value before returning false we'll need to reset its value, or cells at I dot call is equals to value return false, and cell dot value is equals to value. And similarly, let's get the subgrid row, and it is going to be row minus row percent subgrid size, and int subgrid call is going to be call minus call percent subgrid size. And again we'll use one more loop for int I is equals to 0. Nope. For int r is equals to subgrid row r less than there was a loop, let's just copy it, I'm lazy. So let's just copy this loop. Subgrid row, subgrid size, and if our cells at R and C is equals to value, then we are going to return dot value. Cell dot value is going to be equal to value, and similarly we need to reset it. So it should highlight and HIG HLIHT. Okay, so L needs to be capital, and after we have set the valid and invalid condition, we need to also highlight them, and again we'll need to highlight the where is it, we'll need to highlight we are going to use the same loop, so let's pass it here, let's pass it here. Okay, it's not going to suffice, so I'll just need to code it up. So what we are going to highlight, let's get the current row, and it is going to be our selected cell dot row, and current call, and subgrid row is going to be current row minus current row percent of subgrid size, and int subgrid call is going to be current call minus subgrid size. Let's use for int grid size cells at our I, and we'll need to pass our current call dot highlight cells at current row dot I dot highlight. So it is going to highlight the current row, and the cells at subgrid row plus I percent 3 comma subgrid call plus I divided by 3, and it should also highlight. And finally cells at our current row dot select, and I don't think I created any errors here, so we should be able to select them, and cannot be applied, so there is some value where I forgot to pass it, and let's see if we get any errors. So we are not getting any errors, and we'll need to update our colors. So our highlight locked cell color, so when we need to highlight, let's make it black. No, it should be white and then black, and if it is unlocked, then we'll make it blue, and if it is wrong, then we'll set it as red. And okay, so unlocked cell color white and text, and when we select something, we'll convert it to blue and white, and if it is wrong, we'll convert it to white and then red. Okay, and when we reset it, then it is going to go to the default, and if it color will be blue, and if it is wrong, then it is going to be our wrong color. So let's hit play. So hmm. Why is it not detecting? Input dot get mouse button of 0. If hit, we'll debug it a little bit later. So let's hit play first. It is not detecting. We didn't assign the input for now. So let's debug why is it not detecting. So the first thing is, if we have finished and we are not clicking anything, so input dot get mouse button of 0, then we are going to return. Let's add a debug.log clicked. So let's check if we are able to click. So we are able to click it. No issues here. Now let's see if so I added one more debug.log, and we'll see if all the conditions are satisfying, and it is good. We are getting errors. Getting errors means we are learning and we are not trying again both stupid things. So that is the problem with that loop. And why would be that? So let's go inside our cell, and the box collider, okay, it is set to be a trigger, and it has the cell component attached, so it should detect. And our canvas, ignore graphic raycaster. Do we need the graphic raycaster? I don't know. It doesn't matter. So it is detecting the click, but let's check the first condition. Not input dot get mouse button of 0, then it is working here perfectly fine. If hit and let's remove this whole loop. So if we have hit and if we get the component and our component is not equal to selected cell and our not locked. Okay, so it should not be locked. Then we are going to so let's now hit play and let's see. Now it looks much better. So again it is not highlighting. Maybe there is something that is blocking. uh, it should be our canvas. Ignore reverse graphics and yeah, it is not. We are not getting any errors, but it is not even working. Mouse pose 2D vector 2.0 input dot mouse position. Where is the error? Selected cell, reset and highlight. Hmm, 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 hmm. So don't know where the error is, but we can check something like highlight. Let's put those functions at the start when our cells are spawned, and we'll set our selected. Nah, we cannot even do that. So let's set the selected cell to be our cells at 2.2 and let's see if it works. Okay, okay, okay. So many issues. Input, color, highlight, nothing is working. So we'll debug this in the next part and we'll see what errors are there. So let's go inside Unity and let's see what is happening. So we added it here, but it is showing something different. So let's see where the problem is. Cell color is going to be gray and blue, blue, white, white, red, cell and text. So in the previous part we had some bugs and I caught the bugs. So the main issue was with our cell script. So at the start our if the value is 0 then it is not going to be locked. That means we can pass some input, and if there is some number passed then it is not going to change. So this both were interchanged, and also inside this current call there was some issue with this replace to current call, and the autocorrect just switched the current call and current row, so that was also an issue, so do check it. And now what we are, let's first see how it is working. So let's hit play, and we'll click on a grid, and as you can see it is showing all the highlighted rows and subgrids. So if we click on any of the grids, then it is going to show us, but if we click on any of the lock grid, it is not going to show us. So highlight and everything is working fine. Now we need to set up our input, so we'll do that. So for our input, we'll need to create a function inside our game manager, which is going to pass the input from the buttons, and we already created the functions for the cells. So we are just going to call those function again. So reset, select, and whatever this function is. So let's create that function after our reset grid. So it should be after reset grid, yeah. So where is our reset grid? It is going to be public because it is going to be attached to the function button, and we'll call it update cell value, and it is going to need a value. And first we are going to check if has game finished or our selected cell is equals to null, then we are not going to do anything. Then we'll update the value on our selected cell, and after that we'll highlight and we'll check if we are winning. So how we are going to check the win is let's create our function. So we'll check if every unlocked cell is so there is some value and it should not be incorrect. So let's use a for loop. For int I is equals to 0, I less than grid size, j is equals to 0, j less than grid size. If our cell set I and j, if it is incorrect, then it is going to be false. We need to check if it is correct, and also none of the cells should be empty. So ij dot value, if it is 0, then we are going to return false, else the game is going to be finished, and we'll set the has game finished to true. And we will reset all our grids, which is going to be the update win. So for j grid size cells ij dot win, and update win is just going to set it call the update win function, and every cell is just going to be locked, and return, nah, we'll just use return, and it should be finished here. And after we have won, we are going to call the invoke. So we'll wait for 2 seconds, and we'll call our go to next level function. And what our go to next level function is going to do is just restart the game. So this one needs to be public void restart, and inside our restart game we'll just use unity engine dot scene management dot scene manager dot load scene, and 0, there is just only one scene, so we'll just pass the indexing to 0. And let's create our go to next level function. So it should be after our responses. So private void go to next level, and inside our go to next level, we'll first set the level. So player prefs. Mm, mm, mm. So let's just call the restart game. Yeah, we'll debug and set the grid saving and everything later. So almost everything is finished. We just need to save the level, but let's see if everything is working perfectly fine. So we'll need to play the level and finish it, and we'll need to attach the input first. So let's attach our game manager, and the function is going to be the update cell value, and the one is going to have input of 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0 we need to set as 0. And let's also add our restart game function. So it is going to just call the restart game, and let's hit play, and every time it is, did it crash? Yep, looks like it. So for now, for a little bit, I'm going to switch to my yeah, my Unity editor crashed. So the method is not completely safe. uh, Most of the time it works, but sometimes it may not. So the level generation, there may be not enough cells to be a unique solution which has. So the Sudoku generation in which we created, there was a condition, so I used chat GPT, and for easy level generation every Sudoku should have only one solution, and that's why we need to implement the solver script. And so input was changed, not an issue here. Let me go inside Unity and it should detect it. Yeah, now it is detected, and let's hit play. And most of the time it doesn't crash, but as you can see it currently crashed right now. So 1 is okay, 2 doesn't matter, 3 is incorrect because there's already 3, and as that was incorrect it showed us it to be incorrect. And to see if our game has finished, we'll need to finish the whole level, which doesn't looks like it is easy. So let's create a quick hack to finish the level. And what we are going to do is inside our generator, let's set the min squares removed to be just 10. So for fast completing the level, it's our own game, so I'll do that, and we just need to solve 10 levels. And there is some problem for the level generation. So which one is easy? Min squares removed plus min squares removed plus 5. Okay. So let's go inside Visual Studio. Let's go inside our game manager, and we should get the easy level, but it is not giving us the easy level. So edit, let's clear all player prefs. I don't know why I did that, and let's hit play. So why? I'm not going to solve it. We'll find some way to. So here we are passing the difficulty level, which is the easy, medium, and difficult. So if it easy, then min squares removed are going to be 10. Squares to remove minus minus 10 to 15. Okay, and inside our game manager, we are passing easy. Hmm. Start row, start call, row and call, row and call. There should be some bug somewhere, or we should only have 10 of the cells. So let's go inside Unity and let's hit play. Let's 2 is not working, 3, 4, 5, 6, 7, 8, 9. How am I going to solve it? 9, 6, and 9. Let's pass 2, 3, 4, 5, 6, 7, 8, and 2, 3, 4, 5, 6, 2, 2, 9. Okay, so this one is solved. Let's pass 3, 1, 2, 3, 4, 6, 7, 9. Okay, so it is going to be difficult. So why is there the problem? A script should work perfectly fine, and it is good to debug. Puzzle grid, row and call. Mm, mm, Solver dot has unique solution, else it is going to be our temp. Okay, so this while loop there's not any problem. Let's go inside Visual Studio. Generator, solver, and our game manager. So what we can do is let's pass the difficult and let's see what happens now. So the difficult also has almost similar number of checks, and let's pass medium and let's go inside Unity. Yeah, I have one more trick remaining. So to check if it is finished or not, the main issue is squares to remove. So we'll just set squares to remove to be equal to 5. Now it should not create any problems, or there is some problem with this loop here. Random row and random call, random row and random call. So if it is 0, if it is not equal to 0, then we'll set it to 0 and it should have a unique solution. So let's go inside Unity, and now we should only have 5. Again, there are not 5. So there is a problem with our squares to remove. Phew, 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 phew. Solver dot has unique solution while it is greater than 0 minus 0 dot board size, 0 dot board size, random row in temp, grid at random row and random call. Mm, 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 mm. If it has a unique solution, then we'll subtract, else we'll reset. Mhm. And at the end we are going to return the grid. So if else, and it should only be inside the if. Where is the logic breaking? Initialize grid, first row, fill grid. So it is also filling correctly. Yeah, the problem is here. Here? Is it here? If none of the values work, backtrack to the previous cell. Nope, not here. Grid at RC plus 1, RC grid. For each int num and numbers, return false. So where is the problem? Has unique solution. If it is empty cell, then break. Solution count start is going to be 0, greater than 1. Return false, and return solution count is equals to 1. Row and call is going to be empty cell. So it doesn't look like there is an error here. We are already initialize grid, squares to remove. Switch on the difficulty level, easy, medium and difficult. Let's just remove one square and let's see what it is going to do. Okay. Serialize field, private list, cells. I'll need to reassign it. public. Mm, 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 mm. Public list cells. There was some problem. So, I'll need to reassign my prefabs and yeah, they are assigned correctly. Let's hit play. And it didn't create any more problems, but we have our this grid here. And it is going to be a bigger problem to solve. So let's go inside the generator. Initialize the grid. We are filling it. Grid size C is equals to grid size. Okay. Here is the problem. We need to start from 0. Caught one of the problems, so it should start from 0. Where it was inside the fill grid. Okay, so now it is better. Now what we need to do is check again. So as you can see, some typo errors and our whole game got crashed. And now we have 1 2 3. How many do we have? Okay, so there should be around 10. So 2 is not, so let's put the 2 here. 1 2 3 4 5 6 7 and 2 here. Am I recording? Yeah, so I am recording it. And here again we are going to put 1 2 3 and 4. And let's put 1 2 3 4 5 6 7 8. 8 is not working, so that's going to be here. 1 2 3 4 5 6 7 9 here. Let's put 2 here. 2 is not working. 1 2 3 4 5 6 7 1 2 3 4 5 6. 6 is also not working. Let's put 7, then put 6 here, and 1 2 3 4 5 6 7. So when our game is finished, it should restart. So as you can see, the main issue was the fill grid was using the same column, but it should start on a new column. So that was the main issue. 1 2 3 4 5 6 7 8 and 9. And we should get a new level when we start. So let's put 3 here, and 1 2 3 and 4. How many cells? 3. And 1 2 3 4 5 6. Okay, so okay, 2 is it? 3 2 and 6. And so finished, and a new level. So as you can see, that was pretty bit hectic, and also told you it is good to create mistakes and debugging skills will improve. That's how I would go about it. And let's see the main error which caused it. So the main issue was inside our fill grid, where instead of starting on a new row, we just increased the row and the column was set to 8. So I don't know how it went about that. And I think what would have happened is just left rest of the rows and it did not fill any of them. So that was the problem. And in the next part, we'll see how we are going to save and set up the levels. So sorry for the error. And if you did solve it yourself, then it is good. and if you didn't, then just change that C to 0 and it should be solved. And let's go to the next part, which will be the final one. So in the previous part, we set up the win condition, and the game is going to restart when we win. And there were also a couple of bugs which we fixed it, and it was almost most of the bugs are just like one variable you renamed it, or because of autocorrect, and it is hard to catch. And if you know like why it is showing that bug, like in the previous part where the selected cells current row was misspelled, instead of adding the row we add the call, so it was cleared. But in the fill grid where it was checking recursively, we were not able to know that why that was causing the problems. So now what we are going to do is our restart function was also working. We need to save our current grid and just save the current level, and when the game finishes we'll create a new level and save it. And when the game starts, instead only for the first level we are just going to load it, and rest of the levels are just going to save it inside our player prefs. So let's see how we are going to do that. So let's go inside Visual Studio, and our puzzle grid is getting from our generate puzzle. Instead, what we need to do is get it from the player prefs. So let's remove this here, and it is going to be a new int, and we'll pass our board size or grid size. What did we call it as? Yeah, grid size. And we need to get our level, and it is going to be player prefs dot get int, and we'll just call it level, and the default value is going to be 0. And if our level is 0, then we'll create and store level, and we'll pass our puzzle grid, and we'll pass the 1, and our level is going to be 1. Else we are going to get our current level. So get current level, and again we'll pass the puzzle grid, and after that we'll update our level text. So level text dot text is going to be level dot toString, and that should do the trick. Now let's create both of those functions. So the first function is going to be our create and store level, and it is going to take a parameter of our grid and also our level. And let's create a temporary grid, which is going to be from our generator dot generate puzzle, and we'll divide the level by 100, and we'll cast it to our difficulty level. So generator dot difficulty level, so it is going to give us a level, and there are only 3 of them, and we will store it inside a string, and this string is going to be stored inside our player pref. So for int I is equals to 0, I less than grid size. For int j is equals to 0, j less than grid size. Array string plus is equals to temp grid of I comma j dot toString, and we'll also add a comma, and we'll also set our puzzle grid. So our grid ing is going to be our temp grids ing, and after that our array string is going to be array string dot tremend, and we'll pass the comma, and we'll set the player prefs dot setInt, and we'll set the level to be our level, and player prefs dot set string, and this is going to be our grid, and we'll pass our array string. So this is going to create and store the level, and after that we need to get all the levels, so we'll call the get current level, and we are going to pass our grid. It is better to call this grid, and let's get our array string, and it's going to be player prefs dot get string, and what did we name it at? We'll just call it grid. And after getting the string, we are going to array values, will pass array string dot split by spaces, and int index is going to be equal to 0, and we'll use a for loop. For int I is equals to 0, I less than grid size. For int j is equals to 0, j less than grid size. And we'll set our puzzle grid. Our grids ing are going to be equal to int dot parse of array value of I plus index plus plus, and we'll increase the index count, so it should give us our puzzle grid. And when our go to next level is called, we'll first get our current level, so int level is equals to player prefs dot get int, and we'll call the create and store level. Let's pass our new int of grid size comma grid size, doesn't matter, we are not going to use it, and the level is going to be increased count by 1. And I don't think we'll need to do anything else, so check win is also perfectly fine and is valid, and restart game, and I don't think it should cause any more problems. So let's clear the player prefs, and what should happen that it should start at 0, and if there are any problems then we'll solve it. So let's solve this grid. So 1 2 3 4 5 6 7 8 9, and similarly let's pose 2 here, 3, then there should be 2 here, 1 2 3 4 5, and there should be 6, and 9 3 2 6. Let's restart. So here is 9, here's 3, here's 2, here's 6, that should be 4 5 6 7 8 9, and here it should be 1, and 1 2 3 4 5 6 7 8 9 5 6 7, and let's pass the 5, and here let's pass the 3, so 6 8. So it is finished, and we loaded the next level, and the only thing that is remaining to do is instead of calling level.toString, we need to add a level string here. So it should be at the start, instead of calling level.toString, we'll call level plus, and that should be the final thing we need to do. And we almost finished it. I thought it would finish faster, but it took much longer. So it doesn't matter, we have everything perfectly worked up, and the starting levels I've created easy because I just don't want to like set it up, but you can set the difficulty and have different amount of values. uh, don't use insane amount of values. As you can see, the once my Unity crashed, so because of it was not finding any cells to remove, and there would have been multiple unique solutions, and there is no way to like go forward. It just removes the number of cells and checks for all values. So that is the main issue here. And let's clear this grid, and then we'll see what we'll need to do. 3 4 5 6 7, and here let's put 1 2 3 4 5 6 7 8 9, and 1 2, and it should be 4 here, 1 here, 1 2 3 4 5 6 7 here, and it should have 1 2 3 4 here. This one should have 2 1 2 3 4 5 6 7, and how many are remaining? Let's add 1 2 3 here. One is not going to be here, so it should be here. It is not here. Okay, so there is already one. 1 2 3 4 5 6 7 8 9. Okay, so 9 it is, and that should be the 7, and the grid is solved, and we should be go to the level third. That was the simple Sudoku. You can like use different logic, I don't know, but that's how a simple puzzle game is made. Nothing too complicated, but lots of debugging. But if you are good enough, then you can debug in like half an hour, 1 hour. I'm recording, so I just added the mistakes so you don't like get the idea that everything works perfectly fine and it is not scripted. So I have to code everything up, and autocorrect helps a little bit, and sometimes I view the code. So I have GitHub opened my Chrome, and that was it for this part. And this should be the first game. I will try to update more games, and the fast forwarded version will be on YouTube, and I will cut some parts so you won't be able to see it. So if you bought this course, thank you, and the course price will also increase. So if you have bought at the start, it will be around $20, and again I'm adding 10 games, so it should be 50, or maybe I will even change it to $100 if the games are good enough. So thank you for watching, and see you guys in the next game.